Okay, this type of problem is a good problem. It reviews order of operations, multiplying fractions, adding fractions, finding common denominators. This problem really has it all, so it will review a lot of really good concepts. So let's get started. The first thing I want to do is simplify some of these things. So if they had like terms, you could add them, but I don't see any like terms here. I don't see any like terms here, but what you do see here is uh, this 5 multiplied by something in the parentheses, and then there's some parentheses outside. And by a rule of operations, parentheses is always the thing that comes first. Um, it goes parentheses, exponents, then multiplication and division, then addition, subtraction. So parentheses are going to go first. So we're going to work on just this term right here. So we just want to look at the term 5 times z plus 1 over 15. Oh, I wrote x, I meant z. Okay, so what does that equal? Well, let's distribute. So the 5 goes to the z, and the 5 also goes to the 1 over 15. If you don't remember how to multiply fractions, this is just a little side note. That's going to be 5 times 1/15 equals 5 over 15. And what does 5 over 15 equal? Well, that's 1/3. You can reduce that. You can see that 15 is the product of 5 and 3, and the 5's cancel out, and you're left with 1/3. So we said 5 times z, so we get 5z, and then plus, well, we said 5 over 15 is 1/3, so let's write that out. 1/3. Okay, so this is our term. This is how we simplified this inside area. Okay, so now I have this is the original equation. You can see they're the same, so I'll just pull this up so we can work on it. So we have this, and we said this inside, we can get rid of it and copy this one into there. Okay, so now we got rid of that second bit of parentheses. And next what we're going to want to do is distribute this 1/2 to what's inside these parentheses, and distribute this 1/2 inside to these parentheses. Now, there's also another trick we could do. If you notice that there's 1/2 in front of each, well, because it's on each side of the equal sign, we could remember when you have an equal sign, you can do 5 equals 5. And if you multiply one side by 2, you have to multiply the other side by 2 so they stay the same. So if we multiplied 5 by 2, we'd get 10. On the other side, we multiply by 2 and get 10. So we can do that the same thing here. We could multiply this whole side by 2 and this whole side by 2, and that would get rid of our 1/2 fraction. And that's a really good trick. Just for practice, I'm going to distribute this because we know that trick. We could do that. But let's just do it the slightly harder way, and we'll see what happens. So let's first distribute this 1/2 into these parentheses. So we get 3z over 2 plus, and then when you multiply 1/2 and 1/6, you get 1/12. And then we have this minus 1/4. And that equals you distribute this 1/2 to the 5z, so we get 5z over 2. And then plus, you multiply 1/2 and 1/3, that's 1/6. Oop, I didn't mean to do that. 1/6. Okay. So now you can see we need common denominators. I would say usually when we're finding common denominators, we want to find, something they both the denominators go into. And what I see, these are all even numbers, which is good. And our biggest denominator here is 12. And because these are all even numbers, you can see they're all factors of 12. So that's a really good candidate for a common denominator. So basically we're going to go through and try to make these all have 12 in their denominator. So how do we do that for the first one? Well, for the first one, we're going to multiply by 6 over 6, right? Because 6 times 2 is 12. And this one we can leave the same. And this one, we're going to do times 3 over 3. And this one, again, we said to get to 12, we multiply by 6 over 6. And we're multiplying by a form of 1, right? If you multiply anything by 1, that's just itself. We're just changing the denominator here. And to get to 12 from 6, you do 2 over 2. Okay, so let's rewrite all these multiplied out. Well, this becomes 18z over 12. So 18z over 12. And then we had plus 1/12, right? That stayed there like that. And then minus, well, this is going to be 3 over 12. 3 over 12. And that's equal to 5 times 6 is 30, so we get 30z over 12. And then 2 times 6 is 12, and 2 times 1 is 2, so we get, that's plus. And plus, and then 2 times 1 is 2 over 2 times 6 is 12. Okay. And now we see that we have a common denominator across the whole thing. And like I said, we could do this trick up here by multiplying everything by 2. You can add and subtract these, that's fine. But you could really multiply this entire thing by 12. 12. And get rid of the 12s because you're multiplying 12 on each side. So it will stay the same. So why don't we do that? Well, we multiplied both sides by 12, and that gets rid of the denominator, and you are left with 18z plus 1 minus 3 equals 30z plus 2. Okay, so from here you really should be able to solve this. We could move all these non-z terms to the left-hand side and move the z terms to the right-hand side. So why don't we subtract 18z from both sides? That's 30z minus 18z. So we would be left with equals 12z. And then let's see, if we subtract 2, first of all, 1 minus 3 is negative 2, and then minus another 2, well, we get minus 4. So if we divide both sides by 1/12, we get minus 4. Minus 4. Let's move this up over 12, which is minus 1 over 3, which equals z. So that should be our answer. Minus 1/3 equals z. And we check our answer here, and we see that's right.